They found them, 6 of them, shooting out like spokes on a wheel, organized, deliberate, locked to the exact same angle we've been tracking since November. Hubble just processed the data, and what they're seeing shouldn't be possible for a random chunk of ice tumbling through space. These aren't chaotic gas clouds. These aren't random plumes. These are jets, 6 distinct jets, radiating from 3I Atlas at specific angles, and every single one of them is firing along that 110-degree axis everyone's been measuring for weeks. And before you think, okay, cool, comets have jets, listen to what Gemini found 4 days earlier. They pointed their spectroscope at this thing and caught it changing color. Not over months, not gradually changed, blue, significantly bluer than before. It whipped around the sun like something stripped away the old surface and exposed fresh material underneath that. It's now actively venting into space. The chemistry is lighting up their instruments. A cyanogen, carbon chains, all the molecules you'd expect from a comet, except the pattern, the organization, none of it fits what we've seen before. Right now, 2 of the most powerful observatories we've got are both staring at the same object going, what is this thing actually doing? Because the more data comes in, the weirder it gets. Let me walk you through what they saw, and I'm telling you what the raw images show versus what's actually happening are 2 completely different stories. November 30th, 2025, Hubble locks on during closest approach. This is the money shot. Best resolution we're going to get before this thing leaves the inner solar system. They're using the good camera. Sharp optics, 56 kilometers per pixel, and that's detailed enough to see real structure. If there's structure to see, images come down and they're gorgeous, bright, completely useless for finding anything interesting. The inner coma is so bright it's washing everything out. Just this brilliant glow, and around it, nothing, smooth fall off, no features, looks like every comet ever photographed. A fuzzy blob, symmetric, boring. Here's the problem, though. That brightness is hiding everything. The nucleus is buried under its own glow. All that gas and dust streaming off creates this haze that obscures the source. It's like trying to see through thick fog. You know, something's there, generating the light, but you can't see the actual structure, so they run processing on it. Burst method strips away the smooth background brightness so sharp features become visible. You're basically turning down the glare in the center so the fainter stuff around it shows up, but second method enhances anything that changes sharply, suppresses anything that's smoothly varying. Perfect for finding jets because jets are narrow, linear, distinct from the diffuse coma, and these methods don't create data, they reveal what's already there but hidden. Like adjusting contrast to see faint writing, the writing was always on the page, that you just made it visible. Processing runs first pass. The smooth glow starts breaking up unevenly, brighter regions appearing, fainter regions, asymmetries. Second pass with the enhancement filter, and boom, there they are. Lines. Straight lines shooting out from the inner coma. Count them, at least 6 distinct jets, maybe more. Look at how they're arranged though. Not random directions, not spraying everywhere. They radiate from a common center. They're narrow. They stay collimated as they extend outward instead of spreading out. They have specific angles you can measure. This is organized. The symmetry is what stops you. To pull back, look at the whole pattern. The jets appear in opposite sides of the coma. Roughly symmetric across a central axis, not perfect, comets all messy, but close enough that it's obvious something's organizing this around a preferred direction. The axis itself, the line, all the symmetry is built around, it's running at approximately 110 degrees position angle. But this many jets, this organized, maintaining this exact geometry for this long, that's not normal. Because here's what should happen. Comet nuclei spin. Usually every few hours or days, as it rotates, different parts face the sun. Heat up, become active, jets turn on, turn off, sweep around as the nucleus spins underneath them. You see them move, change position, create spiral patterns in the coma. 3i Atlas jets aren't doing that. Same orientation every observation, same pattern, same angles. Either it's rotating incredibly slowly, like weeks or months per rotation, or something else is keeping these active regions locked in position. And whatever that is, it's maintaining paired symmetric jets along a consistent axis for over a month now. You can separate the jets from the main dust tail easily. The tail, that broad diffused structure, follows predictable physics. Sunlight pushes dust, creates a tail pointing away from the sun. You can calculate exactly where it should be, and it's there, right where expected, along with a faint anti-tail from dust left behind in the orbital path. But the jets aren't following that geometry. They're not aligned with the sun direction. They're rotationally controlled, organized around the spin axis of the object itself, internal structure driving emission, not external pressure organizing dust. So we've got visual confirmation of 6 jets, geometric analysis showing symmetry, position angles matching previous measurements. But how do you prove this isn't processing artifacts? How do you confirm these are real and not something the algorithms created? You measure. You quantify, turn the visual into numbers. Hubble teams ran a full circular brightness profile around the nucleus. Draw a circle around the central coma. Measure brightness at every point. Symmetric coma gives you smooth curve. Same brightness all around. Real structure gives you peaks. They plot it. Brightness versus angular position. The curve isn't smooth. It's spiked, sharp peaks at specific angles, each one matching a jet location. The peaks are obvious. Discrete brightness increases at predictable intervals. This is proof. The jets are real. They're bright enough above background that they show up as distinct features in the measurements. This is how you separate signal from noise. Random fluctuations create noisy curves with small irregular bumps. Processing artifacts might create 1 or 2 features in specific spots related to detector quirks. But 6 distinct peaks, evenly distributed, matching the visual features, that's real structure. That's organized emission from the object. Different processing methods give same results. Different people working independently find same jets. The brightness profile confirms what the images show. You're not debating whether they exist anymore. You're trying to figure out what they mean. Hubble gave us structure, but structure doesn't tell you composition, doesn't tell you what's actually venting off this thing or why it's behaving this way. For that, you need spectroscopy. Split the light by wavelength. See what molecules are emitting, what's actually happening chemically. That's what Gemini did 4 days before Hubble caught those jets. November 26, 2025. Gemini North on Mauna Kea, Hawaii. Big 8.1 meter mirror, premier telescope. They pointed at 3i Atlas and ran spectroscopy, not taking pictures, splitting light into component wavelengths, creating a spectrum showing intensity at each color. Immediately, something interesting shows up. The coma looks different at different wavelengths. Blue light? It's diffuse, nearly circular, uniform. This is gas molecules glowing under UV from sunlight. Smooth distribution because gas expands evenly. Switch to red wavelengths. Morphology changes. Coma becomes concentrated, structured, directionally biased, teardrop-shaped with material extending away from nucleus in one direction. This is dust. Red light shows scattered sunlight off particles. And dust doesn't behave like gas. Dust has mass, responds to radiation pressure, gets pushed by sunlight. So you're seeing active separation. Gas and dust release together, but once in space, they evolve differently. Gas expands freely, creates diffused blue halo. Dust gets organized by solar radiation, creates structured red distribution. And you can see this clearly, which means strong emission, lots of material coming off. This confirms Hubble's observations make physical sense. Jets eject both gas and dust. Close to nucleus, they're narrow and collimated. Extending outward, gas disperses into broader coma. Dust gets swept into tail. Inner structure is jets. Outer structure is where jets feed into larger scale distribution. 2 scales, same source, different physics. But Gemini found something else. Something that only became obvious comparing their data to earlier measurements from before perihelion. The color changed. 3i Atlas is bluer now, not slightly, significantly, measurably, confidently bluer. They calculate color index, standard measurement, comparing brightness in different filters. G band minus R band. Basically green minus red. Result is B0.73 compared to pre-perihelion measurements from July and August. That's a major shift toward blue. The uncertainty is small. This isn't noise. This is real change in the object's color. Think about what color means. Red objects have complex organic molecules, carbon-rich compounds processed by radiation over long times. Dark, red, weathered. Blue objects have fresher material, ices that haven't been exposed long. Volatile rich compounds more reflective in blue. The difference between old weathered surface and fresh interior. 3I Atlas spent how long drifting through interstellar space? Probably millions of years. Exposed to cosmic rays, interstellar radiation, occasional dust impacts at speeds high enough to vaporize material. All that creates weathered surface. Radiation breaks down molecules into simpler, darker, redder compounds. Surface gets processed, gets old. Then it enters inner solar system, approaches the sun. Perihelion happens. Closest approach, maximum heating. And that heating does something interstellar radiation couldn't. It removes the weathered layer. Solar heat sublimates surface ice. Gas jets carry away dust. Outer layers get stripped. Meters of material could erode in a single close pass. Underneath that weathered exterior is fresh material that hasn't been exposed. Volatile rich ice. Still pristine, still blue, still active. That's what happened. Before perihelion, it looked red. Old surface, weathered over millions of years. Perihelion acts like sandblasting. Solar radiation heats surface. Ice sublimates explosively. Thermal stress fractures structure, chunks break off. Jets carry away loose material. Old surface stripped. Fresh interior exposed. Fresh material is blue. This explains the brightness spike at closest approach we covered before. Not just closer, so appears brighter, though that factors in. Surface renewed. Albedo increased. Reflectivity went up because dark weathered crust got removed and bright fresh ice underneath got exposed. More reflective surface means more sunlight bounced back. Brightness increases beyond what distance alone predicts. And this fresh material is volatile rich. Frozen compounds that want to sublimate, which means it's active, creating those jets Hubble detected. Jets aren't from old weathered surface. They're from fresh exposed regions where volatile ices sublimate rapidly under solar heating. Surface renewal feeds activity. Activity maintains jets. Jets organize into stable pattern. So you've got a model connecting observations. Interstellar object arrives with red weathered surface. Solar heating strips surface near perihelion. Fresh blue material exposed. Volatile ice sublimates from active regions. Jets form. Organize around rotation axis. Coma develops with gas-dust separation. Color shifts blue. Albedo increases. Brightness spikes. Everything fits. But we need chemistry. Knowing surface changed color tells you something happened. Doesn't confirm what molecules are involved. For that, you need spectral lines. Emission features at specific wavelengths uniquely identifying chemical species. Gemini spectroscopic data shows clear emission lines, not continuum, not just reflected sunlight. Emission, light emitted by excited molecules in the coma. 3 species confirmed: cyanogen CN, diatomic carbon C2, triatomic carbon C3, all carbon-based. All common in comets, all products of organic material being broken down and sublimated under heating. CN is particularly useful as tracer, created when complex carbon-nitrogen compounds break apart. Parent molecules in nucleus, things like HCN or other organics, sublimate and get dissociated by solar UV. Fragments include CN radicals glowing at specific wavelengths. You detect CN, you know there's carbon-nitrogen chemistry. You know nucleus contains organic material. C2 and C3 are pure carbon chains. Come from even more complex carbon compounds breaking into simpler fragments. They fluoresce green under UV, which is why comets often look green. That classic green color isn't exotic elements, just carbon chains glowing. Strength of emission tells you how much carbon-rich material is sublimating. 3I Atlas shows strong C2 and C3 emission, lots of carbon coming off. Compared to solar system comets, CN, C2, C3, these are standard molecules. Every comet shows these. Halley, Hale-Bopp, Hyakutake all had strong carbon chemistry. So composition-wise, 3I Atlas isn't exotic, not weird interstellar material we've never seen. It's ice and organics, same as solar system comets. Interstellar space and solar system formation produce similar basic chemistry, at least for comets, but behavior is unusual. Organized jets, stable rotation, persistent directional structure. These aren't standard traits even though chemistry is standard. So it's not made of something different. Something about structure or rotation or activity pattern is different. Same materials, different organization. The green color connection ties everything together. Ground observers in December reported green coloration in outer coma. We mentioned this before. Color evolution from blue to green to gold. The green phase, that's C2 and CN emission. Gemini confirmed the molecules responsible. When amateurs were imaging and seeing green, they were seeing carbon chemistry, real molecular emission. And timing matters. Gemini observed November 26th. Ground observers confirmed directional structure around December 17th. 3 weeks apart, the chemistry Gemini detected was already there, already active, already producing emissions that would create visible structure ground telescopes later resolved. Molecular emission feeds coma. Coma develops structure. Structure persists because emission source, those active regions creating jets, stays organized. Stack observations chronologically and watch the picture develop. July 2025. Discovery during gamma-ray burst event. Object appears faint and red. November 6th. Europa Clipper UV detects directional structure. First hint of asymmetry. November 26th. Gemini confirms chemistry and color change. Surface has renewed. Emission strong. November 30th. Hubble resolves jet structure. 6 organized jets from common center. December 17th. 19. Ground observers independently confirm 110-degree axis, structure stable and persistent. Every observation adds a piece. Every piece fits. You're building coherent model where interstellar object with weathered surface approaches sun, gets stripped by heating, exposes fresh volatile material. Active regions create jets. Jets organize around rotation axis. Chemistry confirms carbon emission. Structure persists across weeks. What we know for certain. Organized jet activity confirmed by Hubble. At least 6 distinct jets in paired symmetric pattern. Rotation axis orientation approximately 110 degrees. Consistent across multiple independent measurements. Post-perihelion surface renewal confirmed by color change toward blue. Indicates fresh material exposure. Active chemistry confirmed by Gemini. CN, C2, C3 emissions. Strong carbon-based outgassing. Gas-dust separation confirmed by wavelength-dependent morphology. Blue shows gas, red shows dust. Different distributions indicate active separation. What's still not fully explained. Why is rotation so stable? Most comets show rotation changes as asymmetric outgassing creates torque. 3i Atlas isn't showing obvious spin-up or spin-down. Jets maintain same orientation over weeks. Either rotation period very long or something about structure resists torque. Why don't jets sweep around more obviously? If nucleus rotating with periods of hours or days, jets should visibly change position as active regions rotate into and out of sunlight. We're not seeing that variation. Jets appear stable. Why such high albedo after perihelion? Fresh ice is reflective. But maintaining 80% albedo reported earlier is exceptional. That's fresh snow levels. Most comets much darker even right after perihelion. What's keeping surface this bright? Why this specific geometry? 6 jets in symmetric pairs around 110-degree axis. That's organized. Comet nuclei are irregular chunks, not precision objects. Getting this symmetry from random surface features and natural outgassing is possible but unusual. These questions aren't showstoppers. They're next-level investigation. You've confirmed basic structure, chemistry, activity pattern. Now you refine, model, explain details, figure out what makes this particular object behave this way when most comets show more chaotic activity. And while this develops with 3i Atlas, other things happening, because universe doesn't pause. MAVEN, NASA's Mars Atmosphere Monitoring Spacecraft, lost contact December 6th. Communication failure during Mars solar conjunction when Earth and Mars on opposite sides of Sun. Sun's radio interference makes communication difficult. Recovery efforts ongoing. Ground teams trying to re-establish contact. Attempts expected after January 16, 2026, once conjunction ends. MAVEN matters because it's been monitoring Mars' upper atmosphere for years. tracking how solar wind strips atmospheric particles, measuring seasonal variations, providing data on how Mars lost thick atmosphere over geological time. Communication gap means missing data, not catastrophic. Spacecraft probably fine, just out of touch temporarily. Reminder that deep space operations are fragile. One miscommand, one orientation error, one hardware failure, and you lose contact with something hundreds of millions of kilometers away. December 24th, observers in Manorville, New York, caught Titan transiting Saturn's disk. Titan, Saturn's largest moon, bigger than Mercury, only moon in solar system with thick atmosphere. Occasionally, from Earth's perspective, it passes directly in front of Saturn. These alignments happen roughly every 15 years because of viewing geometry required. Need Earth, Saturn, and Titan lined up just right. Scientifically valuable because transits let you do comparative measurements. Measure Titan's atmospheric properties against Saturn's reflected light. Track how atmosphere absorbs specific wavelengths. Compare to earlier transit data. See if anything changed. Cassini gave incredible close-up data during its 13-year mission. But Cassini ended 2017. Any new observations from Earth help fill gap until next Saturn mission. These brief updates remind you we're in busy period. Solar maximum, multiple active regions on Sun, coronal mass ejections affecting Earth's magnetosphere, Mars operations hampered by conjunction, Saturn system visible for rare observations. And 3I Atlas still out there, still active, still moving through inner solar system with organized jet activity that doesn't fully fit standard models. Back to 3I Atlas, because Hubble and Gemini data created complete enough picture that you can synthesize everything. Start with object itself, interstellar. Third confirmed after Oumuamua and Borisov, arrived from direction of Sagittarius, same region as that record gamma ray burst in July. Approach Sun on hyperbolic trajectory, not bound to solar system, just passing through. Closest approach to Earth, late November into early December 2025. Coinciding with these detailed observations, surface composition before perihelion, red, weathered, processed by millions of years interstellar radiation. After perihelion, blue, fresh. Stripped by solar heating, renewed by exposure of interior. Albedo increased, brightness spiked, activity ramped up, chemistry active, cyanogen, diatomic carbon, triatomic carbon, all detected in emission. Carbon-based organic material sublimating from nucleus under heating. Physical structure, compact nucleus, few kilometers across. Buried under brilliant inner coma. Inner coma elongated along 110-degree position angle. Organized structure maintained over weeks. Outer coma extending hundreds of thousands of kilometers. Shows gas-dust separation at different wavelengths. Green coloration from C2 and Cn. At least 6 distinct jets radiating from inner coma. Collimated, organized. In paired symmetric pattern around rotation axis. Rotation. Stable orientation over observation period November into December. No obvious precession. No significant changes in jet position angles. Either very slow rotation or structural mechanism stabilizing orientation despite asymmetric outgassing that should create torque. Trajectory. Continuing outbound from perihelion. Receding from Earth. Heading toward outer solar system. Next major milestone. Jupiter encounter March 2026. Current velocity and trajectory set up for potential gravity assist if no corrections occur, or for deliberate maneuvering if something about this object is controlled. Everything from spectroscopy to imaging to ground observations to space UV converges on consistent picture. Interstellar object showing comet-like chemistry and activity, but with organizational features more stable and geometric than typical comets. Chemistry normal, behavior unusual. That combination keeps this interesting. Think about how much learned in 6 months. July discovery, mostly astrometry and basic brightness. September-October gradually approaching, brightness increasing predictably. November, perihelion passage, color change detected, UV structure observed, chemistry confirmed. December, ground observations reveal stable directional feature. Hubble resolves jets, full geometric and spectroscopic characterization achieved. Each observation refined model. Early on, questions broad. What is this? Where from? Is it dangerous? Got answered quickly. Not dangerous. Interstellar origin confirmed. Trajectory calculated. Next level. What's it made of? Why bright? What's causing activity? Chemistry answered composition. Color change explained brightness. Surface renewal tied to perihelion. Current questions more specific. Why 6 jets in this geometry? Why stable rotation? What mechanisms maintain organization? How does this compare to other interstellar objects we might detect? These are refinement questions, not questioning basic nature anymore. Trying to understand behavioral details. Those details matter because every interstellar object teaches us about conditions in other star systems. 3I Atlas formed somewhere else. Different protoplanetary disk, different star, different chemistry available during formation. Fact that composition matches solar system comets suggests carbon-based chemistry is common. Ices, organics, rocky material seem to be universal building blocks, regardless of which star system you're orbiting. But structural differences tell you about formation environment and ejection mechanisms. How did 3I Atlas get kicked out of home system? Gravitational interaction with planet, close encounter with another star, supernova shockwave, each mechanism would impart different velocities, different rotation states, different thermal histories. Stable rotation we're seeing could be clue to ejection dynamics. Maybe got spun down by interaction, maybe formed with low angular momentum, maybe collisions in original system damped spin. We don't have enough data to choose between scenarios. But point is, each interstellar object carries information about origin. We've only detected 3 confirmed interstellar objects total. Oumuamua, weird shape, weird acceleration, gone before full characterization. Borisov, looked normal, acted normal, gave baseline for typical interstellar comets. 3I Atlas, normal chemistry, unusual organization, teaching us even objects with familiar composition can show unexpected behaviors. Sample size tiny. 3 objects isn't enough to generalize, but it's start. As detection improves, telescopes get more sensitive, observation campaigns get coordinated, we'll find more. Next decade could give dozens of interstellar objects, build statistics, see what's common, what's rare. 3I Atlas might end up typical for certain class, or genuinely unusual even among interstellar visitors. March 2026, next critical test. Jupiter encounter, trajectory calculated. If purely gravitational, path predictable. Jupiter's mass and gravity will bend trajectory, add velocity, fling 3I Atlas back toward interstellar space faster than it came. Standard gravity assist happens to every object passing through Jupiter's influence. But if there's another course correction, another deviation from predicted trajectory, like we saw near Earth, that changes interpretation. One correction could be random outgassing creating thrust, twice harder to dismiss, twice suggests some level of control, or at least reproducible asymmetric emission, creating thrust in useful directions. Not saying artificial, not claiming design. Just saying natural explanations get strained when you stack anomalies. Current observations continue. Every clear night, telescopes track 3I Atlas, monitor brightness for changes, image coma to see if jet structure evolves, spectroscopy when possible to track chemistry variations, astrometry to refine trajectory and detect small course adjustments we might have missed. Data keeps accumulating, models keep getting refined. Monitoring isn't just passive recording. Teams actively planning observation campaigns for Jupiter encounter. What wavelengths to observe, which instruments to use, how to coordinate between ground and space assets. Hubble might get another look if scheduling allows. Gemini can do follow-up spectroscopy to see if chemistry changes as object cools moving away from sun. Radio telescopes can listen for emissions, confirming or ruling out those amateur reports from earlier about periodic radio bursts. This is how astronomy works. When something interesting shows up, mobilize resources. Coordinate internationally. Collect as much data as possible during window when object is observable, because opportunity is limited. 3I Atlas will fade from view eventually as it recedes. Once past Jupiter, too faint for detailed study. You've got months, maybe year, if lucky, to gather all data you can. Data from this object will be analyzed for years. Not everything gets published immediately. Teams still working through observations, calibration, processing, error analysis, peer review. All takes time. What we're seeing now is preliminary results. Obvious features emerging from initial analysis. Detailed papers will come out over next year, digging into specific aspects, jet dynamics, chemical composition variations, thermal modeling, rotation state determination, trajectory refinement. Each paper will add nuance. Maybe someone figures out rotation period by finding subtle variations in brightness we haven't noticed. Maybe thermal modeling explains high albedo, specific ice mixture maintaining reflectivity better than standard water ice. Maybe trajectory analysis reveals tiny periodic variations indicating regular outgassing pulses. All gets teased out with careful analysis over time. But main conclusions already solid. Organized jets confirmed. Chemistry confirmed. Surface renewal confirmed. Stable rotation confirmed. These won't get overturned by further analysis. Details will be refined, but fundamental picture established. 3I Atlas is active interstellar comet, showing organized structure and carbon-based chemistry with surface that renewed during perihelion passage. What that means in broader context, still unclear. But we're building understanding piece by piece, observation by observation. The jets are real, the chemistry is active, the structure is organized, and in March 2026, we'll see what happens when this object encounters Jupiter. Stay tuned, keep watching, and remember that the universe is full of surprises. 3I Atlas is one of them, and we're privileged to be here, documenting it, studying it, trying to understand what it means. This is science in action. Science. This is discovery happening in real time, and you're part of it. Thanks for watching. Subscribe for updates, and we'll see you at Jupiter.